I'm not jumped to the conclusion that I believe that there are, aliens coming from another planet, but I'm open to that, and I think that it's our responsibility, especially when we're seeing that we have a government that is actively blocking information from us. There's a whole bank of these kinds of videos that Congress has not been allowed to see, that the public hasn't been allowed to see. Congress just saw patterns that look like awareness. Not a rumor, not a leak. Actual telemetry, no blinking lights, no radio greeting, behavior that tracks when and how we observe. Brightness changes sync to our watch windows. Minute drifts lining up with planet overflights. Thermal bumps after our high-power transmissions. These aren't one-offs. They repeat enough to flag attention. That is why the briefing happened. Tonight we unpack the evidence paths, what gets counted, what gets filtered out, where natural physics ends and questions begin. We lay out the risk ladder without panic. What shifts for satellites, airlines, and the grid. Then the response plan that keeps our options open. No wild claims, just the strongest tests. If the patterns hold, you'll see why policy moves. If they fade, you'll see how the math caught it. Either way, you get the payoff first. Let's get to work. Awareness doesn't always look like a message. It doesn't have to talk, blink, or broadcast anything. Real awareness can hide inside correlation, the subtle, repeated echoes that line up too neatly with our own actions. That's what triggered the latest conversations in Washington. The first flag came from light curves, brightness spikes showing up right after radar sweeps from Earth-based tracking arrays. Coincidence? Maybe. But when the same pattern repeats across multiple instruments, it starts looking deliberate. The second flag, course drift. Not random wobble, not solar wind. Tiny, consistent shifts that seem to prefer planetary flyovers, as if the object's trajectory chooses better vantage points. The numbers don't scream intelligence, but they whisper precision. Then came the thermal data. Several sensors logged temperature spikes just after high-power communication bursts, the kind used for deep space signals. A lag of minutes, not hours. Enough to notice, enough to wonder. None of this proves a thing on its own. But together, these three markers, brightness, drift, and heat, form a pattern that can be tested, replicated, and measured. They live in real data, not speculation. And that's what caught Congress's attention. Because patterns can't lie. They can only be explained, or not. Two triggers hit at once, and that's what pulled this out of the lab and into the halls of Congress. First, the behavior refused to go away. It wasn't a single spike or a single telescope glitch. Multiple observatories, NASA, ESA, the Rubin Observatory, kept recording the same off-pattern readings. Different sensors, same anomaly. That's what they call non-line persistence, something that doesn't vanish after calibration or better weather. Second, the circle of interest widened overnight. What began as a scientific oddity turned into a cross-agency conversation. NASA brought the data. The Department of Defense flagged orbital timing overlaps. The Space Force wanted a closer look at the tracking architecture. Even NOAA and FAA analysts sat in, because if the readings affected radio spectra or navigation precision, they needed to know yesterday. When science meets security, ears open fast. Suddenly, it wasn't just about discovering a strange object. It was about understanding its behavior before it passed us by. The window to observe was short. Maybe a few weeks of optimal geometry before it slipped behind the sun. That urgency alone justifies a classified briefing. Behind closed doors, one phrase kept repeating, "If the pattern's real, we can't miss it." The stakes weren't about aliens. They were about control, information, and what it means when something out there might be reacting to us in real time. If you like fast, grounded breakdowns, hit subscribe and tap like right now. We don't drag things out here. We cut straight to the signal and leave the noise behind. Here's where things get practical, the Awareness Index. It's a simple 5-point system anyone can follow at home, based entirely on public data. No secrets, no classified filters, just numbers. First metric, brightness versus radar correlation. If the object brightens every time we ping it, that's 1 point. Second, residual acceleration, motion that remains after you subtract gravity, sunlight, and radiation pressure. If it still moves in ways physics can't quite explain, add another point. Third, phase angle outliers. That's when the object glows brighter or dimmer than geometry predicts, as if it's responding to who's watching. Fourth, spectral toggles, certain light signatures shifting exactly when our high-power transmitters activate. And fifth, repeatability across sensors. It's only real if multiple instruments see it, ground telescopes, orbiters, even deep space probes. Add up the points. If two or more climb together week after week, policy moves start happening. Because when patterns line up across systems, it stops being an anomaly and becomes a signal worth acting on. That's when this story truly turns. If this object really knows we're here, there's a clean scientific way to find out. No guesswork, no mythology, just controlled testing. Test 1. The Pre-Registration Protocol. Publish radar schedules in advance. Every pulse, every frequency, every timing window, then watch what happens. If the object's brightness, temperature, or motion shifts right after those windows, that's measurable correlation. Random space rocks don't sync to human calendars. Test 2. On-off illumination. Power our transmitters in a deliberate pattern. On for 10 minutes, off for 20, then measure thermal lag on the object using infrared telescopes. If temperature peaks follow our signal pattern with consistent delay, it's not noise, it's feedback. Test 3. The Geometry Stress Test. Run millions of Monte Carlo simulations, random trajectories under pure physics, and see how often those fake paths match our observed alignment with the planets. If reality keeps beating the odds, you're no longer looking at coincidence, you're looking at intention, or at least a deeper force we haven't modeled yet. Test 4. The multiband crosscheck. Every reading must appear in optical, infrared, and radar bands simultaneously. One telescope can make a mistake. 3 independent systems agreeing within hours, that's confirmation. These 4 tests don't require belief, just patience, precision, and transparency. If any one of them holds, the debate changes from what is it to what does it want? If those patterns hold, if awareness locks in, the effects reach us faster than most realize. When high-frequency signals start interacting with deep space emissions, GPS margins tighten. Positioning systems could drift by fractions of a second, but in navigation that's enough to reroute planes or delay launches. Satellite communications feel it next. Even a minor spectral overlap can shift link budgets, meaning weaker connections, dropped packets, or increased latency across the global network. Then comes atmospheric drag forecasting. If 3I/Atlas outgassing changes solar radiation pressure near Earth's orbit, models built on steady baselines suddenly wobble. That's debris tracking, weather satellites, even space station maneuvers being recalculated. And on the ground, airlines and utilities notice first. Pilots see GPS anomalies before astronomers do. Power grids depending on satellite timing catch phase mismatches. It's not catastrophic, but it's disruptive. And if the correlation keeps repeating, those small shifts become the first tangible sign that something out there might actually be reacting to us. Quick gut check. Awareness isn't a laser show. It's not flashing lights or alien Morse code. It's patterns that quietly track our actions. We change something, timing, power, frequency, and the object shifts right after. Not once, not luck, repeated. That's what gets circled in red inside those congressional briefings. Because repetition means reaction. And if those reactions keep happening after we adjust our behavior, that's when the escalation begins. Procedures kick in. Agencies coordinate. What started as a curiosity becomes a controlled situation. If the data keeps pointing toward interaction, the response must be cautious and tight. No dramatic gestures, no ad hoc transmissions. Keep emissions stable and predictable. First rule, don't improvise messages. Unplanned beacons can create false correlations. Second rule, expand passive sensing immediately. Add infrared, radio, and polarimetric coverage. Book telescope time. Task orbiters. Log everything. Third rule, deconflict crewed missions and priority satellites. Move non-essential vehicles off risky corridors. Protect GPS-dependent operations. The goal is to reduce collateral risk. Fourth rule, create an independent red team. Let skeptical engineers try to spoof the pattern. If they can fake it, we avoid a false alarm. If they can't, confidence rises. Fifth rule, mirror every raw data stream into an open, time-stamped log. Transparency undercuts panic and traps errors fast. Let vetted researchers audit the records. Add a forensic lab lane. Rapid isotope and particulate analysis must be ready if physical samples or captured ejecta appear. Build a fast chain for peer review. Don't forget legal and diplomatic steps. Notify allies. Set brief joint thresholds. And agree on escalation points. Space problems that cross borders need shared playbooks. Keep a public communications plan simple and calm. Say what you know, what you don't, and what you plan to test next. Avoid speculation. Reassure without sugarcoating. Fund a standing sensor surge budget. Rapid response observations cost money and short windows expire. Congress already showed it will listen. Be ready to ask again. Finally, prepare technical fallback options. If a pattern persists, move to controlled quieting of select bands, then run pre-registered repeatable tests. If responses remain, escalate to international panels and higher-level policy decisions. This playbook protects lives, preserves data integrity, and buys time for the facts to reveal themselves. If the signals hold, we'll need discipline more than drama. A new policy concept is already circulating quietly through the agencies: the contact minimalism doctrine. It's built for exactly this kind of scenario, where curiosity and caution have to coexist. Rule 1: observe, don't provoke. Curiosity drives science, but impulse drives mistakes. Watch everything, log every variable, but never alter the environment just to get a reaction. Rule 2: replicate before you react. One anomaly means nothing. 2 in a row means recheck the instruments. 3 independent replications mean you might have something real, and only then do you consider action. Rule 3: run pre-registered tests only. Every planned radar burst, every spectral sweep, every observation window is documented ahead of time. That way the results can't be accused of bias or manipulation. Rule 4: no unilateral messaging. No rogue transmissions. No curiosity pings. If this object is aware, you don't want 10 countries shouting at it at once. Communication, if it ever happens, must be coordinated, deliberate, and transparent. The contact minimalism doctrine doesn't assume hostility or friendship. It assumes uncertainty, and treats that as the most dangerous variable in space. Think of it like wildlife: you observe first. You don't feed it. You don't chase it. You watch how it moves, how it reacts, and only then do you adapt. That's the doctrine. It keeps us smart. It keeps us alive. And it keeps us honest with the data. But what if nature fakes awareness perfectly? What if everything we're seeing, the signals, the timing, the behavior, is just physics wearing the mask of intention? Then the real challenge begins. Because if nature can imitate awareness that well, we'll need sharper filters, tougher tests, and a whole new way to tell intelligence from coincidence. Nature has a way of copying intent. It doesn't think, but it can act like it does. Space is full of illusions that look like design until the math strips them bare. Asymmetric outgassing is one of them. When frozen gases on one side of a comet vaporize faster than the other, the escaping jets can act like microthrusters, nudging the object ever so slightly. To the untrained eye, it looks like steering. Then there are spin-state resonances. If a body's rotation period happens to align with our observation schedules or the geometry of our orbit, it can seem like it's timing its reactions to us. In reality, it's just physics syncing up, coincidence painted as communication. And dust dynamics can do the rest. Tiny particles blown by solar radiation can form antitails, plumes that look like propulsion jets pointing toward the sun instead of away. A natural trick of perspective, but one that has fooled astronomers before. That's why every serious analyst starts with the filters. Equations that remove radiation pressure, solar torque, spin coupling, and outgassing bias. Strip away the physics first. Whatever stubbornly remains after that, that's the part worth losing sleep over. Because what resists explanation is where new discovery begins. This is where discipline matters most, the two-gate certainty model. Every anomaly must pass through both gates before anyone acts. Gate A is physics. You run the filters: radiation pressure, outgassing, dust dynamics, spin resonance, instrumental bias, and remove every natural cause that can mimic intent. If it survives that sweep, it moves on. Gate B is correlation. Independent sensors across different wavelengths, optical, infrared, radar, must all record the same event at the same time within measurable tolerance. If only one instrument sees it, it doesn't count. Only when both gates close, when the event defies physics and repeats across systems, do you escalate. That's the threshold for credibility. The line that separates data from drama. It's not glamorous, but it's how real science keeps its footing when the rest of the world is losing its mind. You're the one running the lab for a moment. What's your move? Do you listen, wait quietly, and collect more data? Do you signal, send a controlled pulse just to see if it reacts? Or do you shield, go dark, and stop transmitting altogether? Drop your pick now, type it, say it, think it. Because in a second, we'll show you the choice that the actual analysts are leaning toward. Here's the ranked response ladder, the structure that keeps reason ahead of fear. Every step is built on verification, not speculation. Level 1, stay passive. Extend telescope time. Keep the sensors running. Build a longer data record. Observation without interference is always the baseline. Level 2, control tests. Turn transmitters on and off in fixed patterns. Publish every log publicly and let outside labs try to reproduce it. If the object reacts the same way twice, the confidence score rises. Level 3, temporary emission quieting. Reduce or pause high-power signals to see if the correlation fades. Protect GPS bands and essential communications. If nothing changes, it's environmental. If the pattern weakens, you've learned something valuable. Level 4. Orbital deconfliction. Adjust the paths of crewed or high-value satellites just enough to avoid any potential interaction zones. No panic, just prudent maneuvering. Level 5. International coordination. If all signs still point to responsive behavior, the matter moves to a UN-level science panel. That's where protocols, communication ethics, and global transparency take over. Each level buys time, adds data, and narrows the unknown. It's not dramatic, it's methodical. The latter makes sure that every escalation is earned by evidence, not by imagination. If something is built, it must shed heat. Passive probes can hide their voice but not their waste. Heat has a signature. It paints the object in mid-infrared like a watermark. Radiators betray design. They sit at stable temperatures. They don't swing wildly with sunlight. They hold a set point because electronics like steady conditions. That creates flat plateaus in the thermal curve, long stretches at nearly the same temperature. While geometry changes, natural ices don't behave that way. As the sun angle shifts, they warm and cool with insolation. The curve drifts. Peaks rise and fall. No plateaus, just weather. So, the test is simple to describe and hard to fake. Track the mid-IR output as phase angle and distance change. If the temperature follows the sun, it's likely volatile physics. If it locks into narrow bands again and again, you're looking at thermal regulation. Add one more check. Look for a dual regime pattern. One plateau during active periods, a lower plateau during quiet periods. That looks like duty-cycled electronics dumping heat through a radiator. Nature can mimic thrust. It struggles to mimic thermostats. Here's how to quantify trajectory intent without hype. Start with chance. Simulate millions of random hyperbolas. Keep speed, approach angle, and solar effects realistic. Count how often those paths produce multi-planet overflights. Use the same distance thresholds we observed. Now weight each pass by a simple habitability index. Earth scores highest, Mars and Venus lower, gas giants least. Compute a composite probability for the observed sequence. Compare it to the random set. Report an intent score on a 0 to 1 scale. 0 means common. 1 means vanishingly rare. Attach error bars. Use bootstrap resampling to capture uncertainty. Show the median and the 95% interval. Add a sanity check. Rerun with shuffled observation times. The score should fall toward chance. Publish the code and inputs. Make replication boring. That's how you keep this honest. When the congressional briefing ended, the talking points weren't about aliens or theories, they were about logistics. Funding for sensor time jumped to the top of the priority list. The fastest way to lose an anomaly is to stop watching it, and everyone in that room knew it. Agencies also agreed to align their data standards. Until now, NASA, ESA, and the DoD tracked objects in slightly different formats. That fragmentation made cross-checking harder. Now they're using the same coordinate systems, timestamps, and uncertainty codes, one unified ledger for every photon and ping. A framework for public metrics took shape too. Congress wants weekly releases showing awareness index trends, energy readings, and raw observation counts. Not press releases, just numbers people can verify themselves. And one instruction cut through the noise. No improvisation, no sudden transmissions, no unapproved tests. The message was simple. Curiosity is fine. Chaos is not. Every move from here on out must be logged, measured, and repeatable. Because in situations like this, restraint is the most advanced technology we have. Here's where we stand halfway through this story. The mystery isn't about lights in the sky or secret visitors. It's about interaction. Something out there appears to react, however faintly, to what we do here. That's the line Congress was briefed on. This isn't a fantasy pitch. It's a structured test program. We're talking schedules, filters, and open data streams. The goal isn't to prove anyone right. It's to trap reality in numbers that anyone can check. And that's the payoff. If the patterns hold, we'll have the first measured instance of an interstellar object responding to human technology. If they collapse under scrutiny, we'll have the cleanest dataset ever collected on how nature can mimic intent.